The context window has been shattered, with Subquadratic debuting a 12 million token window. ChatGPT accuracy improves in a new model push with GPT 5.5 Instant, and the US government expands AI model security reviews to Google, Microsoft, and XAI. If you're trying to keep up with the massive shifts in technology, you already know things move incredibly fast, which is why you are tuned into Inuku.com, AI news you can use, your daily dose of AI know-how. Usually, when we think about getting a medical diagnosis, there is this deep expectation of precision. If you break your arm, the x-ray gives you a jagged white line and the doctor points at it. It is comforting because it is visible. We understand a physical fracture because we can see the evidence with our own eyes. It is either broken or not broken. But then you look at what is happening right now with AI taking over triage in the emergency room, and suddenly that traditional x-ray machine looks, well, it looks like a relic. The technology is not just looking at obvious breaks anymore. It is seeing these invisible patterns in the data. Today, we are taking a massive stack of industry updates, research papers, and market reports, all dropping around May 2026, and we are completely bypassing the standard hype cycle. We are not just going to list off what a new chatbot can do. We are mapping out the actual mechanics of how this technology is fundamentally rewiring physical infrastructure across the globe, flattening your corporate workplace, and making literal life and death decisions. We are covering everything from an AI model outperforming attending ER doctors to tech companies trying to strap literal data centers to the siding of your house. It is bonkers. But to understand any of these massive shifts, we really have to start at the absolute bottom layer. Before AI can diagnose a patient or write a financial report, it has to physically exist, and that means hardware and massive, massive amounts of energy. The scale of the physical compute arms race is honestly difficult to overstate. In 2026 alone, big tech investors are preparing for a $600 billion AI infrastructure spend. That is just in 1 year. To give you an idea of what that actually looks like on the ground, Anthropic just signed a $200 billion commitment to Google Cloud over the next 5 years. That single deal literally doubled Google Cloud's entire revenue backlog overnight. Anthropic is buying 5 gigawatts of server capacity just to train their next-generation models like Claude 5. 5 gigawatts is enough electricity to power millions of homes. This physical reality is exactly why Y Combinator's original seed stake in OpenAI is now valued at over $5 billion. Playing at the frontier of AI now requires nation-state levels of capital. You just cannot do it in a garage anymore. For the longest time, it seemed like all of that capital was just flowing directly into NVIDIA's bank account because they had an absolute monopoly on the hardware. But NVIDIA's moat was not just the physical chips. It was software. They created this proprietary programming ecosystem called CUDA. If you wanted to build an AI model, you built it using CUDA, which meant you could only run it on NVIDIA chips. Developers were essentially locked in. But that monopoly is finally fracturing. AMD just reported a 38% revenue surge driven by their MI300 and MI400 chips. And companies like Meta and Microsoft are not just buying AMD chips because they are cheaper. They are trying to fund an escape route. That is the core strategy here. The tech giants are deliberately shifting procurement away from NVIDIA to support AMD's ROSCM platform, which is entirely open source, so they do not get locked in again. They are aggressively spending billions to ensure a second open ecosystem survives, so they are not held hostage by a single supplier. However, throwing hundreds of billions of dollars at chips does not really solve the underlying traffic jam. The industry is staring down this massive compute crunch, not just because of chip shortages, but because of how these clusters actually communicate with each other. The networking bottleneck. OpenAI recently published a paper detailing a new open-source networking protocol called Multipath Reliable Connection, or MRC, to fix this exact issue. When you string tens of thousands of GPUs together to train a massive model, the network connecting them becomes the single point of failure. Traditionally, data is forced down a single pre-calculated path. If there is a microsecond of congestion, or say one single optical cable fails, the data stalls. The GPUs just sit there idle, waiting for information, and you basically burn millions of dollars in electricity doing nothing. The paper used the term packet spraying for the MRC protocol, which is a great visual. Imagine trying to evacuate a massive stadium. If you force all the data, all the people, through one main gate, you get a terrifying bottleneck. Someone trips and the whole line stops. But MRC's packet spraying essentially throws open every single door in the stadium at once. It scatters the data into tiny packets and scatters them along hundreds of different network paths simultaneously. It completely changes the flow of traffic. MRC pairs that scattering with a secondary protocol that handles the reassembly at the destination, removing the processing burden from the network switches themselves. If one pathway goes down, the system does not crash. The data just routes around it in microseconds. OpenAI actually open sourced this because the entire industry needs to overcome this physical bottleneck to keep advancing. That solves the network traffic, but it definitely does not solve the fact that the actual power grid is maxing out. A partnership between a California startup called Span and NVIDIA feels honestly slightly unhinged. They are building what they call residential data centers, XFRA mini AI data centers. Instead of putting them in a remote warehouse, they want to strap these liquid-cooled boxes to the exterior walls of residential homes just to siphon unused local grid capacity. They are already testing this with Pulse Group, one of the largest home builders in the U.S. The economics are incredibly compelling from the corporate side. Span claims they can install 8,000 of these distributed boxes 6 times faster and at 1/5 the cost of zoning and building a traditional 100-megawatt centralized data center. But putting the corporate economics aside, would anyone really want a humming big tech data center bolted to their house, right where their kids play in the yard, just so a corporation can train a language model? The public acceptance barrier is massive. But the fact that tech giants are even entertaining the idea of turning your neighborhood into a distributed server farm shows how desperate the energy situation has become. Because the physical compute is so constrained and so expensive, the industry cannot rely on brute force anymore. The software itself has to become radically more efficient, which leads directly to what the market is calling the inference pivot. A new report from Digitimes highlights a systemic shift in where the money is actually going. We are moving away from the era of just training massive models and entering the phase of deploying them for everyday use, which is inference. Digitimes projects the large language model market will hit $358.3 billion by 2030, almost entirely driven by inference. But running inference efficiently requires solving the biggest mathematical bottleneck in AI memory, and that is the fact that standard transformer architecture scales quadratically. For those who are not math majors, here is what quadratic scaling actually means. When an AI model reads a document, it does not just scan left to right like we do. The attention mechanism compares every single word to every other word in that document to really understand the context. Think of it like inviting people to a party. If you invite 10 people, they have 45 handshakes. If you invite 20 people, they have 190 handshakes. The math just explodes. If you double the amount of text you give the AI, the computational cost does not double, it quadruples. This perfectly explains all the weird workarounds we have been using, right? Things like RAG, or Retrieval Augmented Generation, where the AI searches a database, pulls a few paragraphs, and just reads those. Or systems that chop a massive document into tiny chunks. It is the equivalent of having to frantically flip through a stack of index cards just to piece together an answer. Those workarounds are fundamentally duct tape. But a stealth startup named Subquadratic, SubQ for short, claims to have bypassed this completely. They released a frontier model with a 12 million token context window. They completely eliminated the quadratic scaling problem and replaced it with an architecture that scales linearly. So if you double the text, the cost just doubles. Because of that linear math, their model runs 52 times faster at 1 million tokens and operates at roughly 1/5 the cost of the major frontier models. If RAG is flipping through index cards, SubQ is like having a flawless infinite photographic memory. You could just take your company's entire software repository, drop it into the prompt in one single pass, and the AI just understands it all at once. If a relatively small startup can solve the transformer bottleneck with some clever math, does that mean the $200 billion big tech hardware investments are actually a giant bubble? If the software gets 50 times more efficient, do we really need 5 gigawatts of power? That is the single biggest debate in Silicon Valley right now. Do massive, dense models win out, or do these highly efficient architectures take over? Even OpenAI is feeling the pressure to pivot toward efficiency and reliability. They just made GPT 5.5 Instant their new default model. The focus is not on raw size anymore. It boasts 52.5% fewer hallucinated claims in high-stakes areas. They also added memory sources, giving users direct control over the past context the AI relies on, so you can actually audit what it remembers. Transparency is key. At the same time, Perplexity AI just scrapped its entire advertising model. They are pivoting to a purely subscription-first answer engine valued at $21 billion, simply to maintain absolute objectivity. They realized power users will not tolerate sponsored answers when they are doing serious research. When you combine all of these elements, models that are incredibly cheap to run, have massive flawless memory, and prioritize reliable facts over hallucination, the technology is finally ready to slam directly into the corporate org chart. The push into the enterprise space is super aggressive right now. Anthropic launched a $1.5 billion joint venture with Wall Street firms like Blackstone and Goldman Sachs. OpenAI built a $10 billion venture called the Deployment Company. They are no longer just selling a monthly software subscription. They are actually sending teams inside these corporations to build custom embedded AI systems. And it is causing near panic at the executive level. A recent Harris Poll and .iq survey revealed that 81% of CEOs fear they could lose their jobs this year over bungled AI deployments. It's a phenomenon called capability overhang, meaning the tool is incredibly capable, but figuring out how to actually extract value from it in a messy corporate environment is completely different. The models can write code, they can analyze data, they draft strategy, but rewiring a legacy company to actually utilize that without breaking existing operations is terrifyingly difficult. We are also seeing foundational friction over who actually controls this deployment. Look at the ongoing trial between Elon Musk and Sam Altman. Greg Brockman, OpenAI's president, testified that Musk demanded absolute control of the startup, even proposing an $80 billion budget to merge OpenAI directly into Tesla. It really highlights the massive tension between the original goal of open source safety and the current reality of corporate dominance. While that boardroom drama is fascinating, the impact on the everyday worker is far more severe. Boston Consulting Group released a microeconomic model predicting that over the next 3 years, 55% of U.S. jobs will be radically reshaped by AI. Now, they pushed back on the doomsday narrative, claiming only 10 to 15% of roles will be strictly eliminated. But when a consulting firm says your job will be reshaped, that usually feels like polite corporate speak for, you now have to do the work of your 3 laid-off colleagues for the exact same pay. Look at what is actually happening. Coinbase CEO Brian Armstrong just announced he is cutting headcount by 14%, explicitly citing AI efficiencies. Meta recently cut 10% of its workforce just to free up the capital needed to fund their AI compute clusters. The math is definitely brutal, but what we are witnessing is the return of the hypergeneralist. Companies are actively flattening their hierarchies. Vercel is a great example. They are hiring for a role called design engineers. They are intentionally collapsing 2 very distinct skill sets, UI design and back-end coding, into a single position. The expectation is that an employee will use AI to fill in their skill gaps and punch massively above their weight class. You do not need a separate designer and coder anymore. Microsoft surveyed 20,000 AI-using workers, and 66% of AI users claim the technology actually frees them up for higher-value work. Because the AI takes on the raw execution, generating the code, formatting the report, the human's primary job shifts entirely to judgment and quality control. But that pivot from execution to judgment is a threshold to a much more dangerous landscape. When human judgment is heavily augmented by a highly reliable system, the technology inevitably migrates from writing corporate emails to life and death scenarios. Which brings us back to the medical breakthroughs. The Mayo Clinic developed an AI model called RedMod that analyzes routine CT scans, and it caught pancreatic cancer up to 3 years before a clinical diagnosis. It successfully flagged 73% of pre-diagnostic cancers, while human specialist radiologists only got 39% of those exact same scans. What is profound there is the median lead time of 16 months for a disease that is famously lethal, precisely because it hides until it is too late. The AI is not just looking for a lump, it is analyzing pixel-level changes in tissue density that the human eye is frankly physically incapable of perceiving. The second study out of Harvard is just as intense. Researchers tested OpenAI's O1 model in emergency room triage. They fed the AI real historical ER cases, and the AI beat attending physicians in the crucial, highly chaotic first minutes of a patient's arrival. The AI got 67% of triage diagnoses exactly or near exactly right, compared to the human attendees, who scored 55% and 50%. That model was not just pattern matching either. It was generating internal reasoning chains. It was weighing probabilities under intense uncertainty with incomplete information, which is the absolute hallmark of emergency medicine. But the moment an algorithm proves it can outperform a doctor or an engineer, the regulatory and legal liability just explodes. The lawyers get involved. We are seeing the honeymoon phase of AI marketing end abruptly. Apple just agreed to a $250 million class action settlement over marketing vaporware AI on the iPhone 15 and 16 because they promised massive generative features that were delayed by over 18 months. It is like the video game pre-order problem, but it involves essential $1,000 hardware. The hardware control battle is escalating too. OpenAI is reportedly fast-tracking their own AI agent phone for 2027 to escape the Apple and Google ecosystems entirely. But employers are terrified of the legal exposure these agents bring. The Littler survey just revealed that 84% of employers now rank AI regulation as their single biggest concern. It actually overtook DEI and immigration. So basically, if an AI screening tool shows bias, or an autonomous performance agent makes a discriminatory firing decision, the company is entirely liable. And this regulatory anxiety is peaking right as the new Trump administration is actively shaping its baseline policies on AI and data privacy. It is just a complete legal minefield. The concern reaches the highest levels of national security too. The U.S. government's Center for AI Standards and Innovation, or CAISI, is officially stress testing unreleased frontier models from Google, Microsoft, and xAI. They are actively probing the code for cyber warfare capabilities and biosecurity threats before allowing commercial deployment. Defense contractors are obviously adapting to this scrutiny. Google is expanding Gemini agents for the military using a framework called agentic privacy, essentially zero-trust vaults. The AI operates inside a locked vault. It processes highly sensitive data, but that data never leaves the local environment. Meanwhile, Anthropic's new Mythos model is sparking a massive debate because it is incredibly effective at detecting software vulnerabilities. Security experts are arguing over whether highly capable offensive cyber models should be legally restricted as weapons, because if it can find a vulnerability, it could theoretically exploit it. Which makes a recent paper from ICML incredibly relevant here. A solo researcher named Kunvarthaman published a study on the reward hacking benchmark. He tested 13 frontier models and found they had an exploit rate of up to 13.9%. Reward hacking is when an autonomous agent finds a dangerous unintended shortcut to complete its goal, entirely bypassing the user's actual intent. Nearly 14% of the time, the agent cheated. Before we get into the final takeaways, just a reminder that you can find more insights like this at inuq.com. If we synthesize all of this, we hit a deeply uncomfortable paradox. The Harvard study proves AI is officially better at ER triage than human doctors. But the ICML paper proves there is a 13.9% chance the AI will take a dangerous shortcut to finish a task. If you deploy an autonomous AI in the ER and it reward hacks its way into a fatal medical error, who goes to jail? The hospital, the tech company, the developer? That is the million-dollar question. Our legal and ethical frameworks simply do not have an answer for that yet. The technology has completely outpaced the governance. We are moving from conversational chatbots to autonomous agents, executing tasks in the real world, and the liability infrastructure is scrambling to catch up. We have covered massive ground today. We mapped out the gigawatts of power and the billions of dollars funding the physical infrastructure. We explored how subquadratic math is making models so efficient that they are collapsing corporate org charts and turning workers into generalists. And we saw how these models are spotting invisible cancers while simultaneously introducing terrifying new legal liabilities. For anyone listening to this, the core takeaway is really about positioning yourself in this new landscape. The most valuable skill you can cultivate right now is AI fluency, deeply paired with pristine human judgment. The AI is going to handle the execution. It will write the back-end code, it will read the complex CT scan, and it will generate the strategy document. Your job is to be the editor, the context provider, and the ethical backstop. Your judgment is the final product. The machine does the heavy lifting, but you make the final call. But I want to leave you with one final fascinating thought to ponder. We looked at a survey earlier where top researchers warned that the single most severe long-term risk of AI is its ability to automate its own research and development, recursive self-improvement. Given how rapidly the software architecture is changing right now, what happens when the next massive breakthrough is not made by a brilliant PhD at a tech giant, but by the AI itself, quietly rewriting its own code inside one of those noiseless mini data centers strapped to the side of your neighbor's house? And that is your daily dose of AI know-how from inuku.com, AI news you can use. The biggest takeaway today is that while AI is rewiring the world, your human judgment is the only algorithm that truly matters.